Hello everyone, I'm Rosamel Caetano, one of the reporters from Group T. In this video report, I'll be covering a section of Module 9's basic radio hardware, in particular, broadcast equipment used in transmission, the antenna system. Now, this report may come off as a bit technical in nature, but I think it's still very interesting to know and to learn more about it. Before we begin, let me share with you the topic outline. First, we'll define what an antenna system is. Then, we will go through its types and explain how they work. And finally, look into the future technologies that could shape radio broadcasting. Since I'm the last reporter for this module, let me also give you a quick summary of the topics that have been covered by my group mates. In the previous reports, my group mates discussed the broadcast equipment used in production, such as microphones that capture sound, tape recorders and players that store and play audio, and the broadcast console, which serves as the main control for mixing and managing audio sources. The demagnetizer, which erases recordings from magnetic tapes so they can be reused. They also discussed and reported about the transmitter, which converts audio signals into radio waves, leading to my report, the antenna system. So, what exactly is an antenna? You've probably seen on TV shows or videos from the 90s where someone climbs up to the roof and adjusts a metal rod to fix the TV or radio signal. That metal rod is actually an antenna. In simpler terms, the antenna is like a receiver that listens to signals sent through the air. As defined in the book Wireless Communications and Networking, the antenna system is the interface between the radio system and the external environment. So it's a device that either transmits or receives electromagnetic waves. It acts as the connection between the transmitter inside the station and the outside environment, where the signal spreads and reaches its audience. So, how does an antenna system help in the radio broadcasting process? To visualize, this is how it works. For example, let's say a radio station wants to broadcast music. It all starts with a transmitter which sends out that signal as an electrical current. Next, that signal goes to the antenna. The antenna turns the electrical signal into invisible waves that travel through the air. Those radio waves spread out until they reach another antenna connected to a receiver. The receiver could be a radio or even your phone. Finally, the receiver turns those waves back into sound, which is what you hear when you tune into the station. So, to summarize, that transmitter sends, the antenna broadcasts, and the receiver picks up the radio waves. So, without the antenna system, the signal would just be in the air and no one would hear the broadcast. That's why the antenna system is very important in the radio broadcasting process. So, antenna systems can be categorized according to their structure, directionality, or application. For the purpose of this presentation, we'll look at the ones used in radio broadcasting. So, there are five main antenna systems currently used in modern times. So, we have the high power directional and omnidirectional antennas, VHF and UHF, FM and AM radio broadcasting antennas, satellite uplink and downlink antennas, 5G enabled and IP based transmission antennas. Now, if you look at the antenna systems on the right, they may all look the same to you, but they serve very different purposes. Some can be tall metal towers you see outside broadcasting stations, while others are small enough to fit inside your phone. I'll go over these types and let me know if you're familiar with any of them or you have seen them around your community. So, first we have the high powered antenna systems, the directional and omni antennas. So, high powered antenna systems are antennas used by radio stations to send strong signals over long distances. They can be divided into two types. We have the directional antennas. They're the classic antennas with a large dish and with a stick in the middle. It is designed to focus radio signals in a specific direction. The focused signal allows for a greater range and signal strength in the desired direction, making them ideal for point to point communication. The example I shared previously about climbing a roof to fix a signal, that is an example of a directional antenna. So, omnidirectional antennas is a type of antenna designed to send or receive signals in all directions in horizontal plane. Unlike directional antennas, omni antennas are ideal for wide coverage areas. An omni antenna will generally look like a stick protruding from the ground. In a nutshell, radio signals are broadcasted on two different frequencies. We have the VHF and UHF broadcast antennas. The VHF, or very high frequency antenna, is used for FM radio and some older TV channels. It is best suited for long range communication and outdoor applications. UHF, or ultra high frequency, on the other hand, is mostly used for TV and some modern digital or community broadcast systems. They're usually mounted on tall towers or buildings to cover large urban or regional areas. UHF doesn't travel well through buildings because its waves are shorter. They're commonly used in TV broadcasting, wireless communications, mobile phones, GPS, satellite communications, or radar systems. Do you recognize any of these, or do you have them in your home? On the left is an FM antenna. FM antennas are used for high frequency broadcasting between 88 and 108 megahertz. They're made of metal parts like dipoles or panels, often stacked or arranged in circles to cover more area. They send signals mostly horizontally or in a circular pattern, giving clear sound locally or regionally. Next are AM antennas. These work at lower frequencies, around 530 to 1700 kilohertz. They're usually vertical poles called monopoles, built to carry long distances. Sometimes, multiple poles are grouped together to direct the signal better. Next, let's take a look at uplink and downlink in antenna systems. When local radio stations want to share their programs across countries or continents, they can't just rely on regular FM or AM signals. This is where satellite antennas come in. So these are the big dish shaped antennas you might have seen on rooftops or in remote areas. They communicate via satellites orbiting the Earth to send and receive radio programs. So here's how it works. Uplink is when a radio station sends its program up to a satellite. Downlink is when another station or relay point receives the signal from the satellite. It's like catching the program so it can be broadcasted locally. So while the antennas are the physical dishes, uplink and downlink are the sending and receiving processes that allow radio signals to travel very long distances. Okay, so these days, radio isn't just about big towers and traditional signals. Some radio stations use 5G networks or the internet to send their programs. The antennas here act like a bridge connecting the station to the network, so radio can travel digitally to other networks, online platforms, or relay points. This means broadcasts can reach multiple places quickly, often in real time, and can even include extras like interactive features or high quality sound. So basically, these antennas help radio go digital, making it faster, more flexible, and more connected than ever. At the moment, only a few countries, such as the US, Germany, France, Spain, are running trials or pilot projects for 5G and IP based transmission. So now that we've learned about these antenna systems and how they're used, it's very important also to talk about where radio broadcasting is headed. So, from my presentation, you can assess that traditional radio relied on a physical broadcast tower and a receiver, but it is now slowly moving online. The growth of digital platforms has changed the radio industry. Trends such as internet radio, podcasts, even satellites have reached a global audience to create new possibilities for both broadcasters and listeners. As technology keeps evolving, radio will continue to grow and adapt. So that is the end of my video report. I hope you're familiar with the different types of antenna systems, how they work, and the future trends in the broadcasting industry. Before I end my video, I'd like to share my discussion questions with you. My first question is: have you ever lived in an area without a good antenna system? And how did that affect your access to information? Second, in practicing DevCom, how important is it to keep up with modern trends such as internet radio or podcasts? I'm looking forward to hearing your answers and having an insightful conversation with you. Again, this is Rosamel. Thank you for listening, and I'll see you again in the next module.